Good morning, students. So today we will solve some problems on Gauss-Seidel method of load flow. So in figure, 4-bus system is shown. Bus number 1 is slack bus and remaining buses are PQ bus. No PV bus is there. So first we will solve problem considering all buses as PQ buses apart from slack bus, and later on we will include PV buses also. Right. So we know that for PQ buses, specified quantities are P and Q. So all quantities shown are in per unit. So this is P2 at bus number 2. This is P2. This is Q2. Similarly, this is P3 and Q3 and P4 and Q4. So variables for PQ buses will be V and delta. So we are required to evaluate V2 delta 2, V3 delta 3 and V4 delta 4. All 6 variables for 3 PQ buses. We have to apply Gauss-Seidel method of load flow, and we have to produce result just after first iteration. No need to check the tolerance condition. Just first iteration. After first iteration of Gauss-Seidel method of load flow, we need to find out the values of the 6 variables corresponding to 3 buses. Clear? So data for this power system is given as, these are the connections between 1 and 2. So see, the 1 and 2 are connected with this line. So the R and X per unit values are given as shown for all the connections. I think no connection is missing. 1 and 4 are not connected, so no data for that, right? So remember the steps while applying Gauss-Seidel method of load flow for solving any power system network. So step number 1 was read system data and then formulate Y. So this data is same which we used already while formation of bus admittance matrix. So we know how to formulate Y bus when data are given. Just check it. I think these data are taken from Nagarath and Kothari book. So you can find there also. So we know how to formulate Y bus knowing these data. R plus Jx will be Z and 1 upon Z will be Y corresponding. Y elements will be evaluated and we can construct Y bus. Right? So next step will be assume initial values. So initial values of variables, and variables are V and delta. So I am rubbing this. Just note down this. We will use frequently. So V and delta means V2 delta 2, V3 delta 3, V4 delta 4. So write the equation for VIR or simply VI. So general equation for VI is 1 upon YII, where I may be 2, 3, 4. So write general equation Pi minus J Qi upon Vi star, right? Minus K equal to 1 to N Yik Vk. K is not equal to I. So this is the general equation for writing Vi phasor. So for I is equal to 2, 3 and 4, we will write it separately. And while applying Gauss-Seidel method of load flow, don't forget to put the updated value of variables, right, in any iteration. So start with bus number 2. Just write for I is equal to 2, it will be V2 and iteration number 1. We have just started our iteration, so first iteration. So we will write here 1. You know the values of this 2 and 1, right? So in place of I we have written 2. It means we are going to write for bus number 2. And this 1 indicates iteration number 1. This phasor indicates that we are going to evaluate both magnitude and phasing. Is not it? So this will be, so I is taken as 2. So wherever I is there, we will write here Y 2 2. I is taken 2. So it means YII is Y22. and Pi means P2. So write directly. P2 values are given, right? So it will be 0.05. First write equation, otherwise you will get confused. So okay, P2 minus J Q2 upon, have you assumed initial values? So step number 1 was read system data, and step number 2 is formulate Y bus. After that, assume initial values. So initial values of variables, so you need to assume. So before that, you need to assume V2 0. 0 means initial, right? So tell me what should be initial value. Okay, let us take the slack bus variables. You may take different value also. So you may take magnitude as 1.04 per unit and angle as 0 degree, same as that of slack bus. So for all buses, because all buses are PQ buses. So for all PQ buses, variables are V and delta. So initial values of V and delta are required to be assumed. So the same value can be assumed for third bus equal to, is not it? Any doubt here? So we have assumed initial values of all variables to be evaluated, and we have started our first iteration. So here it is V2, what it will be? Star minus, so we have k equal to 1 to n, so 1 includes this also. K not equal to I means we are going to write for second bus, so second bus will not be there. So we may write separately because just we have 3, except this we have to write for this and this. So 3 terms of this can be written separately. So this will be I is 2. So y ik will be, for k is equal to 1, 2 1. Isn't it? So 2 1 V1. Right? First one is slack bus. So no need to write 0 1 2 because we are not going to evaluate the specified parameters in any iteration. Right. So next will be, I am writing here. So next will be k is equal to 1. So now k is equal to not 2. 3. K will not be equal to 2 for I is equal to 2. So 3. So for 3 it will be y 2 3. I is 2 here. We are going to write this. See, remember I is 2. So wherever I is there, 2 will be there. So y ik will be 2 for k is equal to 3, 2 3. Is not it? So minus y 2 3 and k is 3, so v3 and this is PQ bus. So both magnitude and phase angle are variables, so we need to write phase. Then k is equal to 4, n is 4, right? So for k is equal to 4, y ik will be I is 2 4 y 2 4. Okay, so we are going to write for first iteration r is equal to 1. So till I minus 1, I is 2, r will be there, and I onward r minus 1 will be there. So for r is equal to 1, r will be 1 or r minus 1 will be 0. So till here no problem. By the way, this is slack bus. So afterward you will write r minus 1, that is 0 and that is 0. Are you getting this? So while applying Gauss-Seidel method of load flow for any iteration r, the values of the variables till I minus 1 are taken as r. The values of the variables calculated in present iteration, and I onward we are taking the values of the variables evaluated in previous iteration. So this is our first iteration. So all values of the variables will be previous iteration value, that is nothing but for first iteration. Previous iteration is not done, that is initial values. So these are initial values. Are you getting or not? Clear to all?
Yes.
Okay. So put the values. Now just you need to evaluate. So y22, tell me the value of y22. y22.
3.667.
Okay. 3.66. 667
minus J11.
minus J11. Okay, this is the value of Y22. P2. So P2 is 0.5. Put here 0.5. What about here? Minus J or plus J? Okay, this is minus J. Q2. And Q2 is minus 0.2. Be careful. Is not it? Q2 is and P2 is 0.5. If minus sign is there, then you need to take that. So Q2 is minus 0.2. So in place of Q2 you will write minus 0.2. So minus minus this will now be plus 0.2 upon. So for first this will be initial value, is not it? V20 star. So V20 you have assumed as, put the values quickly. 1.04 angle 0 degree. Y21 V1. What is Y21? Y21 minus 2 plus J6. Okay, this is Y21. What is V1? So V1 is nothing but 1.04 for slack bus. It is already specified. Put that value into 1.04 angle 0 degree. Okay. Write for Y23. Tell me the value of Y23. I am writing here minus Y23. 0. It is minus or plus?
Minus 0.667.
Okay, so write in bracket minus 0.667
Plus J2.
plus J2. So this is the value of Y23. V30 you have assumed as into 1.04 angle 0 degree. So next one is the last one, Y24. Tell me the value of Y24.
Minus 1 plus J3.
Minus 1 plus J3 times and V1 V40. So V40 is same. It is initial value 1.04 angle 0 degree. Fine. So just evaluate it. You know how to evaluate. While multiplying, better just transform this rectangular form into polar form. And multiply magnitudes together, add the phase angles together and solve it. So tell me the final value. So the final value is coming out to be, just note down and verify it at home, 1.038 angle 2.46 per unit. So you have evaluated the variables corresponding to bus number 2. Those are V2 and delta 2. So V2 is coming out to be 1.038 per unit. Just note down. Now we will utilize this updated value of V2 while calculating V3. Clear? Okay, just note down. I will rub it again. Any doubt till here? Just cross check it at home. So next we will write V3. Next target is to find the variables of bus number 3. We started from bus number 2. That has been done. So for bus number 3, I will be, tell me, I will be here 3. Iteration is first only. Unless all variables are evaluated, the iteration is not completed. So we have started our first iteration and we have just evaluated variables corresponding to bus number 2. So we will repeat the same for bus number 3 and 4. Then iteration 1 will be completed, and if asked, then second iteration will be started. But in this problem, it has been asked find the values of the variables starting flat voltage profile. If stated, then take it. Otherwise, by default, you can take the same flat voltage profile, means same initial values, flat voltage profile, right? So for I is equal to 3, wherever I was 2, just put 3. So this will be equation, right? What about here? V3 0. We have not evaluated V3 1, right? So it will be 3. Here it will be P3 minus. And what about this? Wherever I is 2, put 3. Y3 1, V1. Y, this will be 3 2. Is not it? I is not equal to 3 now, but it will be 2. So right here, Y I K. So I is 3, K is 2, 3 2, V2. So V2 1 has been evaluated now. Up to I is 3. So up to I minus 1, that is 2, we will take the updated values. So V2 1 has been evaluated, so no need to take the previous iteration value. Use present updated values of the variables, right? So what to write here? 1. Very good. So next will be Y I2 is done. I3 will not be there. I4 will be there. And I3. So 3 4. V4 0. I onward take the previous iteration value. So first focus on I. Right. So put the values of these. So P3 is given as minus 1. So right here minus 1. Tell me the value of this. First, Y33. Y33 is from the bus admittance matrix. Tell me the values. Minus
3.667.
minus 3.667. Okay, it is positive plus
Minus J11.
minus J11. Okay. Whatever the value of Y33 is there, just take from the bus admittance matrix and put here. So P3 is minus 1 and Q3 is plus 0.5. So here, by default the sign is minus. So take it. And tell me the value. 5. Minus 1 minus J5. Just take it. V3 0 is same as V2 0 and whatever it is, right? So as it is. Now put the values of Y34. Okay, just put the values. You know how to put the values now, right? Everything is written now. So I am writing directly the value of this phasor. So whatever this is coming out to be, anyone yet not calculated? So directly write 1.056 angle minus 4.542 minus 4.542 per unit. So we have evaluated V2 1 and V3 1. The last one will be V4 1. Clear? Okay, so I am rubbing all. Just note it and evaluate it at home and cross check it. Any doubt till here? So what is left now? So this will be V4 1, first iteration value. So that will be Y44 P4 minus J Q4 upon V4. So for first iteration write 0. This phasor star. Now tell me Y I1, that is 4 1 V1. I is 4 now, so it will be 4 1 V1. So take the element from the Y bus Y41 corresponding to 4th row and first column and put that phasor here. V1 is already given, it will be constant throughout for slack bus, right? So next will be YIK VK. So Y1 V1, Y2 V2, that is 4 to V2. So minus Y42, tell me, V2 1, right? Up to I minus 1, that is up to 3, the variables has been updated in present iteration. So next will be Y43 V3 we have evaluated, right? And any other term? No, because I is not equal to k and I is 4, so it's not equal to 4. So the values of these three terms will be substituted here, and finally it will be, just write down, 1.047 angle minus 0.48 per unit. Just cross check it at home. Any question till now? See, in our problem, the 4-bus system data was given and it was assumed that all buses except slack bus are PQ buses. Now just modify the same problem. Let now the bus number 2 is now PV bus. So for PV bus, a specified quantities will be
P and
V. So let this is P, P2, right here P2, all values in per unit. P2 is this and V2 is same as that of slack bus, magnitude 1.04. So these two are a specified quantity. Just we are modifying our previous problem. Now bus number 2 is PV bus, and for PV bus Q limits are there. So write Q limits also. So Q limits are 0.2 min, or you may write like that. Q2 should be between the limit and 1.0, all values in per unit. So for PV bus, a specified quantities are P and V and the Q limits. Fine. So again, after first iteration, find out the values of variables. So variables now will be for this bus, PV bus.
Q and delta.
So Q2 and delta 2 are required to be evaluated, and remaining two buses are as it is, that is PQ buses. So V3 phasor and V4 phasor are required to be. Got the problem? Okay. So how to start? For the same system. So till now we have system data, we have Y bus, same Y bus. Whether buses are PQ or PV, Y bus will be same for the same system. So for bus number 2, first we need to evaluate which variable? Q. So right here, formula of Q. So Q2 is not it.